One of the key points in the bicycle industry when you produce competition bicycles is product development. Without product development, there is not a chance to compete on the highest level in the industry. Our first setup is to make a wish list what we want from the frame. What do we expect to go into aerodynamics, to go into strength, or to go into lightweight. Having all the information booked in our wish list, we already know which kind of a product to develop. We have to choose between carbon fiber, high-end, mid-end or low-end fibers. We have to choose between the way of making a carbon frame. In certain price points we choose for aluminium. Also there are different materials to use. Plain gauge, double butted and triple butted, hydroformed or bench-stroked materials. Having our wish list and our startup development, we start making our first drawings. First drawings are done in 2D. These are translated to 3Ds. After the 3Ds are done, we can do our stress analysis.
This allows us to visualize the stress impacts on the frame, and if needed we can do the necessary modifications before going into production and doing the first prototypes. The analysis you see on the screen displays the deformation of frame of the rear triangle when applying force onto the frame. The zones indicated in color display the stress level around the bracket area. So this image gives a nice display of the force applied on the rear triangle of the frame, especially the zones that light up in green, blue and red show us where the main force is applied when cycling. These are very important areas to us, and we apply the necessary reinforcements or make the necessary changes to the frame when we see a certain zone lights up in red.
In aerodynamics we even make a second step. After the 3Ds and the stress analysis are done, we make first from the 3Ds plastic molding. EPX molds that shows us the final product that we can take to the wind tunnel for refining and testing to get the best track outcomes possible. After the 3Ds are finished, we open our first mold in a medium size. When this mold is finished, we get our pilot run production. These frames will go to the lab to do the testing, measurement, to see that they are in the same way as our stress analysis showed us digital. When these are in the same level, then we take the frames to the NEN standards. We do our tests for all the NEN norms, first in our manufactories. Afterwards, we bring them to our NEN certificated lab in Europe. After the NEN norms and standards are measured and done, we give the first frames to our local Ridley test team. They will use it on training for several weeks and give us final feedback on the riding conditions and the riding feelings of the product. When they have all given the green light, we give our first frames to the proto team. They will start testing the product at the highest level in competition cycling. When they give the final okay, we can go to mass production. From the wish list to a final mass production, we take about 2 years. In the end, it's you who's going to use our frame, so we cannot cut any corner in our product development.
To demonstrate the difference between a lightweight Ridley frame, such as the Helium, and a frame designed for strength, such as the Damocles, a quick and simple test using a sharp-edged falling weight was undertaken. The 15-kilogram weight hit the side of the top tube of each frame with a force of 25 kilograms per square centimeter.
We just witnessed an impact test on tubes. Side impact on tubes is something that will happen during crashes. You can see clearly the difference between a lightweight frame and a frame designed for strength. The super light frame, you saw during the impact that the tube was completely squeezed flat. From the result of squeezing the tube flat, you see a delamination of the carbon fiber on the middle of the top side of the tube and on the middle of the downside of the tube. On the impact area, you basically don't see any difference. Because the tube is flexible, it will bend down and you get delamination on the top and on the downside of the tube. On the strength frame, which is designed for the side impact strength, we increase our carbon fiber on the impact areas. And if you look at this frame, on the strength designed tube, you could see from the impact movie that the tube stayed in the same form as it is designed. So there is no diffraction on the top side, there is no diffraction on the side since the tube stayed in the same conditions. The only impact that you will see is the damage on the paint where the impact touches the frame. Of course, the force of the impact can be different in different circumstances, so it's not a guarantee that you cannot break a strength design tube, but there's very clearly a big difference between a strength designed tube and a super lightweight designed tube.